In this video, we're going to look at what makes an indicator or dummy variable and how we can use it, how to define it, and so on. So in short, a dummy variable is one that has only two possible values, either 0 or 1. A value of 1 will indicate that that particular observation belongs to a given category that that particular dummy variable defines. Or 0 would mean it does not belong to that category. Okay, that's what a given dummy variable is. So for example, if you have a data set that you've taken from people and you want to have a variable that defines whether a given observation is from a male or a female member of the population. So if you define X as gender, then you can say X is equal to 1 if the observation is made from a female. So in which case if you have a 0, that would automatically mean that it is not female and presumably male. Another example would be married or not married. Again, there are two possible values for this variable. So you can say 1 means married, 0 means not married. Okay, so it's the opposite. In high school, so if whether the person has graduated high school or not, so 1 would mean you belong to that category or the value is affirmative, or 0 means otherwise. So your textbook gives a small numerical example, no analysis here, just to understand how this thing will work in combination with other variables. So you don't have to have dummy variable all by itself. You can have regular variables and dummy variables occurring together. So you have a response variable which is salary in thousands, and you have an independent variable years of experience X sub 1, and then you have X sub 2 is gender, and let's say 1 defines gender is female and 0 defines gender is male. So suppose if you run the analysis and this is the regression estimate or equation that you come up with from the regression analysis, then how do you interpret, how do you use this information? Okay, so here is the general equation, y hat equal to 47 plus 3 x sub 1 minus 5 x sub 2. Now remember, x sub 2 can only take two possible values, 1 or 0. So if you enter 1 here, like here, so you get 47 plus 3 x sub 1 minus 5. So the regression equation boils down to simply 42 plus 3 x sub 1 if x sub 2 is 1, which means for females. For females, that is the regression equation. Now, on the other hand, if you put 0 for x sub 2, and that would be for males, then the regression equation is simply 47 plus 3 x sub 1. So you get two different lines, one for the dummy variable equal to 1 and one for dummy variable equal to 0. So here is how the equation will look like. So 42 and 47 as the intercept and the slope being exactly the same with respect to the years of experience. Now this is all good if the given category has a given variable has only two categories. So gender is male or female, or married or not married. But what if the categorical variable has more than two possible values? Okay. So if the categorical variable has k possible categories, okay, then we can define a dummy variable for each category, but it turns out that you should only include k minus 1 dummy variables in the analysis when you run the regression analysis. So let's look at an example now. Suppose we want, we have a sample of the College of Business graduates. And let's assume that there are 5 possible majors. So accounting, finance, management, marketing, and human resource management. So technically we can define one dummy variable for each category. So d sub 1 is equal to 1, d sub 1 first dummy variable. If major is accounting, if major is not accounting, so it could be any one of the other 4, then we code it as 0. So that would be one dummy variable. Then we define a second dummy variable, and this time it is for finance. So if a given observation, a given sample, major is finance, then you put a 1 there for that second dummy variable. and 0 otherwise, and so on. So you have 5 dummy variables, okay, but when you run the regression analysis, you must only use k minus 1 of them, or 4. Of this 5, we need to include in the analysis only 4 of them, not all 5. Okay, and that's because if you have 0 for d sub 1, 0 for d sub 2, 0 for d sub 3, 0 for d sub 4, that automatically means that particular observation belongs to the 5th category. So we don't need the 5th dummy variable to fully define this categorical variable. Okay. So we need only k minus 1. How many categories are there? Minus 1 is the number. So if you look at the gender itself, gender has 2 possible values, 0 or 1. So all you need is 1 dummy variable that fully defines every observation in the data set. Same here, if you have 5 categories, you need only 4. Okay. If you define 5, that's fine, but don't include all the 5 of them in the regression analysis. If you do, then during the process of regression analysis, a matrix is created, and the matrix inverse of that matrix is needed to be able to estimate or calculate the values of the slope coefficients. And if you include all of them, all 5, then this matrix becomes singular. Okay, singular matrix cannot have inverse. It is like singular matrix is like a value of 0, and if you inverse the value of 0, if you go 1 over 0, what do you get? That's undefined. So same thing will happen if you include all 5 dummy variables. You get into singularity matrix situation, so the whole process cannot work. And therefore, okay, remember, this is important. You need exactly k minus 1 dummy variables, no more, no less. If you define more than k minus 1, meaning all k possible dummy variables, then you get to singularity. And if you define anything less than k minus 1, you will not going to fully define all the observations in the data set. So you need exactly k minus 1 dummy variables if the categorical variable has k possible values. So what you're going to do now is you take away this categorical variable, take it out, and in its place you put k minus 1 dummy variables. So that is how you will redefine the data set before you run the regression analysis. Okay, so here in this example, what we're going to do is to use the dummy variable concept to define which season a particular data observation belongs to. So you can use indicator variables to indicate which season a particular value belongs. So here, suppose we have quarterly Walmart sales, and we have independent variables lagged by 1 quarter, the GDP, and then which quarter it belongs to, and there are 4 possible values. So what we're going to do is to replace, take this quarter observation out and put in its place, remember there are 4 possible values here, so we need 3 dummy variables. So we'll put in its place 3 dummy variables. So let's define the dummy variables as q sub 1 if quarter is 1, q sub 2 if quarter is 2, and q sub 3 if quarter is 3. And then our model will look like this. So the intercept, slope coefficient with GDP lagged by 1 quarter, and then the 3 dummy variables, 1 for each of the 3 quarters. And then of course if all these 3 q variables are 0, and that would mean it is the 4th quarter. So let's now look at this example in Excel.